Let's take this container that contains methane, CH4, and propane, C3H8. Now, each of these gases is exerting certain pressure in the mixture that is called the partial pressure of that gas. So, methane is going to have a partial pressure in the mixture, and propane also has a partial pressure in this mixture. According to the Dalton's law of partial pressure, the total pressure in this container is equal to the sum of these two partial pressures. So it's equal to the partial pressure of methane plus the partial pressure of propane. For example, if we have that the total pressure is equal to 10 atmospheres and we have a 50-50 mixture, 50% of methane and 50% of propane, then the partial pressure of methane is going to be half of this because it's 50%. So we can write down that in this case the partial pressure of CH4 is equal to 5 atm, and same for propane, the partial pressure is equal to 5 atm atmospheres. Now, what about if the mixture has, let's say, 60% of CH4 and 40% of propane? How do we find here? We find that the partial pressure of CH4 is equal to the 60% of 10 atm. How do we find it? Multiply 0.6 times 10 atmospheres and we have 6 atmospheres, and we do the same for propane. We write down that the partial pressure of propane is equal to 0.4 multiplied by 10 atm, and so we have 4 atmospheres. So the general formula for this is given by that the partial pressure of any gas in the system is equal to its mole fraction, which is given in this Greek letter, but we're just going to call it X, multiplied by the total pressure of the system. This is what we were just doing. We're multiplying 0.6, 0.4, 0.7 by the total pressure of the system. And so that percentage of the gas is given by mole fraction. The mole fraction of propane in this case would be equal to the number of the moles of propane divided by the sum of number of the moles of propane and methane. If we have, for example, a 3-gas system, let's say in addition to these two we have gas A, whatever that is, then in this case, if we want to find the mole fraction of propane, here we also need to add the moles of gas A. And same, if I want to find the mole fraction of methane, I'm going to divide the moles of methane by the total moles of all gases. One thing that you need to remember is that the mole fraction, the sum of the mole fraction, let's say you have 3 gases, A, B, and C, has to be equal to 1. It cannot be more than 1 because each of these is the percentages and we cannot have more than 100%. And so once we determine the mole fraction of the gas, we can find the partial pressure, we can find the total pressure if we have the partial pressure in any other type of calculations. Let's look at one example. What is the partial pressure of hydrogen in a 3-component mixture? Methane, nitrogen, and hydrogen. So the first thing that we want to do here is write down what we have. We have the moles of each gas, so let's write down the moles of the hydrogen is 0.730. We have the moles of the nitrogen, 0.54. We have the moles of the CH4, so this is 0.456. What else do we have? We have the total pressure. Let's write down here, P total is equal to 2.65 atmospheres, and what we're trying to find is the partial pressure of the hydrogen in this system. Step 2, what you want to do is you write down this equation, this formula, and you look from here what you have and what you don't have. We're trying to find the partial pressure of the hydrogen. So let's put it this way. The partial pressure of the hydrogen is equal to the mole fraction of the hydrogen multiplied by the total pressure of the system. We have the total pressure and we're missing the mole fraction of the hydrogen. So this is what we need to do now. Let's find it. So the mole fraction of the hydrogen is equal to the moles of the hydrogen divided by the sum of the moles of all the gases in this system. Hydrogen, we have nitrogen, and we have methane. Okay, so let's write down the numbers. We have 0.73 moles, and we're going to divide this by the number of the moles of the hydrogen. We added number of the moles of the methane and also for the nitrogen, and this gives us 0.423. No units, it's a ratio of moles to moles. All of these are moles here. This is the mole fraction of the hydrogen, or in other words, this is the percentage of the hydrogen. How many percent of the mixture is hydrogen? It's about 42%. And so finally what we want to do is we want to write down that the partial pressure of the hydrogen in the system will be equal to the mole fraction 0.423 multiplied by the total pressure, which was 2.65 atmospheres. And this is equal to 1.12 atmospheres with 3 significant figures. This is how we can find the partial pressure of each of the gases. In fact, here, if I were to find the partial pressure of the nitrogen, I would first find the mole fraction of the nitrogen and then use the same formula, and same we can do for methane.